In less than 24 hours, Yellowstone experienced two explosions at the exact same location, Black Diamond Pool in the Biscuit Basin area. But what has scientists paying close attention right now is not just the fact that there were two explosions, it is that the second one was even more powerful than the first. Normally, when underground pressure finally releases, the system temporarily settles down afterward. That is how many hydrothermal explosions inside Yellowstone have behaved for years. But this time, the sequence did not follow the normal pattern scientists expected to see. The first explosion launched rocks larger than baseballs into the air, destroyed sections of the tourist boardwalk, and blasted steam and mud across the basin. Yet less than 28 hours later, the ground erupted again with even greater force. That raises a troubling question. If the pressure had already been released, why was there enough energy underground to produce an even larger explosion almost immediately afterward? Thermal cameras captured the moment rocks and steam exploded out of the ground within seconds. There was no warning, no time to react. Scientists are closely monitoring a possibility that is becoming harder to ignore. The hydrothermal system beneath Yellowstone may be starting to shift in ways we still do not fully understand. For decades, Biscuit Basin was considered one of the quieter areas inside Yellowstone National Park. Millions of visitors walked across its wooden boardwalks every year, stopping to photograph the colorful pools, bubbling water, and rising steam that made the area look both beautiful and strangely peaceful. Black Diamond Pool, in particular, was never viewed as one of the park's most dangerous hydrothermal features. There had been small disturbances reported in the past, including minor events in 2006 and again in 2016, but nothing severe enough to place the site under major scientific concern. No towering eruptions, no violent blasts, no signs suggesting that something dramatic was building underground. To most visitors, it appeared stable, just another quiet geothermal pool, surrounded by steam and mineral-covered rock. But Yellowstone's underground systems do not always give visible warnings before they change. A shifting network of superheated water, volcanic gases, underground fractures, and intense heat moving through layers of rock far below the surface. Scientists have long understood that these hydrothermal systems can remain calm for years, and then suddenly become unstable without notice. That is exactly why the events of July 2024 shocked researchers. A location that had stayed relatively quiet for decades suddenly exploded with enough force to destroy infrastructure and send debris flying through the air. And before scientists could fully explain the first event, the ground erupted again. Do you think Yellowstone is entering a new phase of activity? Or is this still part of a natural cycle? Comment normal or shifting below. The first explosion at Black Diamond Pool happened without a single second of warning. There was no major earthquake beneath the basin, no dramatic spike in underground activity, and no visible signal that gave tourists or park officials time to react. One moment, the area looked completely normal. The next, the ground violently erupted. Superheated water, mud, steam, and rocks blasted into the air with enormous force. According to reports from Yellowstone officials, some of the rocks thrown from the explosion were larger than baseballs. Pieces of debris landed across the basin while thick steam clouds surged upward from the crater. The wooden boardwalk built to safely guide visitors through the area was heavily damaged within seconds. What made the event even more alarming was how quickly it happened. Its hydrothermal explosions are different from volcanic eruptions because they often provide little or no warning at all. There is no slow-moving lava, no towering ash column visible for days beforehand, and no dramatic buildup most people associate with volcanic disasters. Instead, the pressure builds silently underground until the system suddenly fails. Footage released after the event showed rocks flying through the air as boiling water and steam burst out of the pool. Scientists later confirmed this was not a small geothermal disturbance. It was a genuine hydrothermal explosion powerful enough to physically reshape part of Biscuit Basin in moments. And yet, as shocking as the first explosion was, scientists would soon realize something even more unusual was about to happen beneath Yellowstone's surface. Stay updated on Yellowstone, extreme weather, and geological events worldwide. Subscribe now and join our growing Weather Today community. At first, scientists believed the explosion at Black Diamond Pool could be explained by a relatively familiar process inside Yellowstone's hydrothermal system. Over time, underground pathways can slowly become clogged by mineral deposits carried through superheated water. As those pathways seal shut, steam and volcanic gases become trapped beneath the surface. Pressure continues building until eventually the ground can no longer contain it, triggering a sudden hydrothermal explosion. That explanation made sense after the first blast. A quiet location suddenly releasing years of accumulated underground pressure was dramatic, but still scientifically understandable. The explosion damaged the boardwalk, launched rocks into the air, and reshaped part of the basin. Yet researchers initially viewed it as a localized pressure release event. But then the second explosion happened. Less than 28 hours later, the same area erupted again, and according to the USGS, the second blast was even more powerful than the first. That detail completely changed the scientific conversation surrounding Biscuit Basin. Because under the normal pressure cooker model, the first explosion should have reduced pressure underground, not increased it. Once the trapped gases escape, the system is expected to temporarily stabilize. Instead, Yellowstone appeared to do the opposite. The second eruption threw material even farther and with greater force, suggesting that additional heat, gas, or superheated fluid had rapidly moved back into the system from below. That is the part scientists are struggling to fully explain right now. Something beneath Black Diamond Pool may still be feeding energy into the hydrothermal network, even after the initial explosion released pressure. And if the underground system is actively shifting, researchers still do not know how deep those changes extend, or what could happen next beneath Yellowstone's surface. When most people hear about an explosion at Yellowstone, they immediately imagine lava, ash clouds, and a massive volcanic eruption. But what happened at Biscuit Basin was something very different, and in some ways, even more dangerous to people standing nearby. The explosions at Black Diamond Pool were hydrothermal explosions, not volcanic eruptions driven by rising magma. These events are powered by superheated water trapped underground under enormous pressure. Deep beneath the surface, water can remain in liquid form, even at temperatures far above boiling, because of the intense pressure surrounding it. But when that pressure suddenly breaks, the water flashes into steam almost instantly. The expansion happens with explosive force. Rocks, mud, soil, boiling water, and debris are violently launched into the air within seconds. There is often no visible warning beforehand. Which is why hydrothermal explosions are considered one of the most unpredictable natural hazards inside Yellowstone National Park. Scientists point to past disasters to explain how dangerous these events can become. In 2019, White Island in New Zealand experienced a sudden phreatic eruption caused by superheated water beneath the crater. 22 people lost their lives. Monitoring systems were active at the site, yet there was still no warning before the explosion occurred. Yellowstone contains one of the largest hydrothermal systems on Earth, with hundreds of geysers, hot springs, mud pots, and steam vents connected through an enormous underground network. Most of the time, these features appear calm and harmless to tourists. But the explosions at Biscuit Basin are a reminder that enormous energy is constantly moving beneath the surface, even when the ground above appears completely quiet. Following the back-to-back explosions at Biscuit Basin, scientists immediately began examining Yellowstone's monitoring data for signs of a larger volcanic process developing beneath the park. So far, the most important indicators associated with a supervolcano eruption remain absent. According to the latest information from the USGS, there has been no major spike in earthquake activity beneath the basin. Instruments tracking ground deformation have not detected significant uplift around Yellowstone's caldera, and researchers have not reported evidence suggesting magma is rapidly moving toward the surface. From a volcanic perspective, those are reassuring signs. But the situation becomes more complicated when scientists discuss what the monitoring systems cannot currently do. Yellowstone's sensor network is designed to detect large-scale geological changes such as widespread seismic swarms, major gas shifts, or large movements of magma deep underground. What the system cannot reliably predict are small, localized hydrothermal explosions like the ones that occurred at Black Diamond Pool. That means the explosions happened first, and only afterward did the instruments record the event. There was no advanced warning telling scientists exactly when the ground would rupture. Researchers are now closely watching changes in gas emissions, especially carbon dioxide and hydrogen sulfide levels, as well as any new seismic activity that could emerge in the coming weeks. The instruments are focused on Biscuit Basin more intensely than before. The question scientists are trying to answer now is whether these explosions were isolated incidents or early signs of a deeper shift happening beneath Yellowstone's hydrothermal system. When scientists say Yellowstone's hydrothermal system may be shifting, they are not necessarily talking about an imminent supervolcano eruption. What they are describing is a possible change in how heat, gas, and underground fluids are moving through the complex network beneath the park. And that network is far more dynamic than most people realize. Yellowstone is not powered by a single chamber sitting directly beneath the surface. Research over the past several years suggests the heat feeding the system may travel laterally through deep, underground pathways connected to a massive mantle plume far below the region. That means the movement of heat and pressure inside Yellowstone may not follow simple or predictable patterns. Some areas inside the caldera remain relatively calm for decades, while others suddenly become active. Underground fractures can open or close. Mineral deposits can block pathways that once allowed steam and gas to escape. Water can begin flowing into new zones beneath the surface. It's changing pressure conditions in ways that scientists cannot fully map in real time. That is why the activity at Biscuit Basin has captured so much attention. Black Diamond Pool was considered relatively stable for years, yet it has now produced increasingly intense hydrothermal disturbances within a short period of time. 2 explosions in less than 28 hours, with the second one stronger than the first, suggest that something in the local underground system may be behaving differently than before. At the moment, there is still no evidence pointing toward a catastrophic volcanic eruption at Yellowstone. But researchers are paying close attention to whether the underground plumbing beneath Biscuit Basin is entering a new phase of activity. Because if the system is truly shifting, scientists need to understand whether this is a temporary fluctuation or the beginning of a longer period of instability beneath one of the most closely watched geological regions on Earth. One of the most unsettling parts of the Biscuit Basin explosions is that scientists still do not have a complete explanation for why the second blast became more powerful so quickly. The current monitoring data provides important clues, but it does not yet tell the full story of what may be happening beneath Yellowstone's surface. Researchers are now focusing closely on changes in gas emissions around Biscuit Basin, particularly carbon dioxide and hydrogen sulfide levels. Shifts in these gases can sometimes reveal changes in underground heat flow or the movement of fluids through hidden fractures beneath the hydrothermal system. Scientists are also watching for new seismic activity, even very small earthquakes that could signal fluids migrating through rock below the basin. At the same time, recent geological research has complicated the picture even further. Scientists now believe Yellowstone's heat source may not rise straight upward from beneath the caldera as once assumed. Instead, heat and magma may travel laterally through deep underground pathways connected to a distant mantle plume. That means disturbances deep within the system could appear at the surface in ways that older models were never designed to fully predict. For now, researchers are being careful not to overstate the danger. There is still no evidence suggesting Yellowstone is approaching a super eruption. But there is also recognition that the hydrothermal system beneath Biscuit Basin is behaving differently than it did in the past. The challenge facing scientists now is not just monitoring Yellowstone, it is understanding whether these explosions were isolated geological events or the early signs of a deeper process that is only beginning to reveal itself beneath the park. Yellowstone National Park welcomes nearly 4 million visitors every year, making it one of the most visited natural destinations in the United States. Millions of people walk the boardwalks, stop beside steaming pools, and stand only a short distance away from some of the most active hydrothermal features on Earth. Most visitors experience Yellowstone as a controlled and safe environment, where danger feels distant behind wooden railings and warning signs. But the explosions at Biscuit Basin revealed how quickly that sense of safety can disappear. The boardwalk near Black Diamond Pool was specifically designed to keep tourists at what was believed to be a safe distance from the geothermal features below. Yet the explosion in July 2024 destroyed sections of that infrastructure within seconds. Rocks larger than baseballs were launched through the air while steam and boiling debris blasted across the basin. Scientists emphasize that hydrothermal explosions are especially dangerous because there is currently no reliable way to predict the exact moment they will occur. Monitoring systems can track broader geological activity, but they cannot provide immediate warnings before an individual pool suddenly erupts. That means anyone standing nearby during the explosion would have had almost no time to react. The Biscuit Basin Boardwalk remains closed following the event. And park officials continue reassessing how close visitors should be allowed near these unstable hydrothermal areas. Because Yellowstone is not just a tourist destination, it is a living geothermal system that can change violently without warning beneath the surface. Scientists continue to stress that Yellowstone is not showing signs of an imminent supervolcano eruption. The major warning indicators widespread ground uplift, intense earthquake swarms, and large-scale magma movement are currently absent from monitoring data. That remains reassuring. However, the explosions at Biscuit Basin have still raised serious scientific questions. 2 hydrothermal explosions occurring less than 28 hours apart at the same location, with the second blast stronger than the first, is not a pattern researchers can easily dismiss, especially at a site that had remained relatively quiet for decades. Scientists are now closely monitoring Black Diamond Pool for any additional activity. A third major explosion could force researchers to reevaluate how this area is classified and monitored in the future. At this stage, no one knows whether these events were simply a temporary fluctuation or part of a larger shift happening beneath Yellowstone's hydrothermal system. But one thing is clear. The ground beneath Yellowstone has already spoken twice in less than 28 hours. And scientists are still trying to understand whether the system has settled down, or if something deeper is still moving below the surface. Subscribe now for the latest Yellowstone updates and breaking geological events worldwide.